Hi DSA Math 1 students, welcome to day 1 comparing shape, center, and spread. I'm Miss Hamilton, and in this video we're going to do a couple of refreshers from our statistics unit, and then I'm going to do a couple of practice questions from the day 1 supplementary materials with you so that you can go and do our day 1 Google form to kind of practice what you learned in this video. I would encourage you guys, if you don't already have it, to pause this video, go grab some paper and a pencil so that you can take notes and then use that later. All right, let's get started. So the acronym that we learned when we started our statistics unit was SOX, and those letters stood for shape, outlier, center, and spread. These were kind of some key ways that we described statistics that we were able to see. So shape kind of talked about if I made a picture like a histogram or a box plot, this showed us how the data was distributed. So was it like all symmetric? Was it more to one side or the other? So we learned 3 different shapes. We learned approximately normal, which was completely symmetric and kind of looked like a mound. So approximately normal. And then we learned skewed to the left. So the skew talks about where the tail of the distribution is. So this distribution has most of the data on the right-hand side, and then the tail is off to the left-hand side. So we call that skewed to the left. And then finally, skewed to the right, most of our data is on the left-hand side, and our tail is to the right. One silly way to remember this that I know I taught my students, and you guys may have seen it too, is if you pretend that your distribution is a whale, there's its eye, there's its mouth, there's its little blowhole. The tail right here tells you which way it's skewed. So grab the whale by the tail. On the right-hand side, your distribution is skewed to the right. Grab your whale by the tail on the left-hand side, your distribution is skewed to the left. All right, finally, sorry, not finally, but next, we talked about outliers. So we learned the formal way to calculate if something was an outlier, but the basics of it is any number that is unusually large or unusually small for our data set, we consider an outlier. The issue with the word unusual is we need an actual mathematical way to determine what is unusual. So we calculated things called fences. We said that anything that was bigger than our upper fence was considered an outlier, and anything smaller than our lower fence was considered an outlier. So we found our upper fence by taking our upper quartile, so Q3, and adding 1.5 times the IQR. And we'll talk about IQR in just a minute in case you don't remember that. And then to calculate our lower fence, we did Q1 minus 1.5 times the IQR. We also learned a trick in our calculator that if we graph the box plot, it will, especially if we use that option where it shows you the outliers, it will show you the outliers as like a dot on the outside of the box plot. So that's another way you could use to figure out if a data set has outliers. All right, center and spread were ways that we definitely use to describe our distributions. If we didn't want to show everybody all the data, we could talk about the center and the spread, and it would give them a good idea of what the data looked like. So center, we used mean, which is just our average. So to get that, we add our numbers together and divide by the number of numbers. And then our median is the middle number. So we would line those numbers up from least to greatest and cross them off until we get the number in the middle. And then our spread, we learned 3 different measures of spread. So we learned range, which is our maximum minus our minimum. We learned our IQR, which is Q3 minus Q1, upper quartile minus lower quartile. And then we learned the standard deviation, which we didn't learn how to calculate this by hand, but we did learn in our calculator it was the SX when you went to one variable statistics. So the last thing that we want to make sure we remember is when we have outliers, some of our measures of center and spread are better at telling us what our data actually looks like than others. So the median and the IQR, these are resistant to outliers, which just means if you remove an outlier, these two summary statistics are not going to change too much. The mean, the range, and the standard deviation are all highly affected by outliers. So if we have a data set with an outlier, we want to talk more about the median and the IQR so that people get a realistic view of what that data looks like with that outlier. All right, if you've got any questions on this part, there's a place in our collaboration document for you to ask those, so feel free to do so. Now I want to talk to you guys about box plots. So we learned about both box plots and histograms. We're going to focus today on box plots. So the box plot shows us our 5-number summary, which is our minimum, our lower quartile, our median, our upper quartile, and our maximum. And each piece of the box plot is 25, shows us 25% of our data. So if we see a section of our plot that's longer than another section, like this section is the longest section, that doesn't tell us that there's more data there. It just tells us that the data between Q1 and the median is more spread out than the data between the minimum and Q1, so on and so forth. The last thing I want to remind you guys about box plots is I've already kind of spoken to this a little bit in the calculator, but when you see a box plot that has either like a star or a box or something out here, this value is the outlier. And that could also be at the front of the box plot. It's just a way to show you that there is one unusually large data point, and then it kind of cuts the whisker off so you're better able to see the shape without the outlier. All right. Once again, if there are any questions on this, there's a place in the collaboration document for you to ask. We're going to do 2 examples together now. So if you have your DPS supplemental packet, we're going to look at questions 4 and question 6. If you don't, that's no problem. Just kind of continue to take notes on your paper. So question 4 says the average height of students in Sarah's class is 148 centimeters with a standard deviation of 10 centimeters. In Angela's class, the average height of students is 152 centimeters with a standard deviation of 7 centimeters. Whose class has more consistent heights and why? So the key word here is that we're looking for things that are more consistent. So we are talking about spread. And if we think back to our first slide, spread is measured by standard deviation, not by average. So I'm going to go ahead and cross off everywhere that talks about an average height, so I don't use those. So what we're really looking at are our standard deviations. So the first one says Angela's class has more consistent heights because the standard deviation is less. So more consistent would mean that the data is closer together, and standard deviation is less also means that the data is close together. And it's true that Angela's standard deviation of 7 centimeters is less than Sarah's standard deviation of 10 centimeters. So it looks like A is actually our answer. A good multiple choice tip, though, is to kind of keep reading through, make sure you didn't miss anything. So we'll look at B. Sarah's class has more consistent heights because the standard deviation is more. That's not true. That's kind of the opposite of what we said in A. And then Sarah's class has more consistent heights because the average is less, or Angela's class has more consistent heights because the average is less. Because these are talking about average and we are talking about consistency, we can automatically know that C and D are not correct. All right. If you've got a question about question 4, once again, you can go to that collaboration document and type it, and your classmates or I can answer anything that you're still wondering about. The last question that we're going to look at together is question 6. So Eric surveyed 3 different restaurants about the amount of time they spend in hours on washing dishes in a week. He found the mean and the standard deviation of the data as shown below. Which of the statements is true? So let's start with statement A. Restaurant B spends more time on washing dishes than restaurant A and C because it has the highest standard deviation. So remember, standard deviation is measuring variation or spread, not more or less time. So we know that anything that talks about more or less time and then is talking about standard deviation, we can automatically eliminate those. That's not the right measure or summary statistic for us to be using. So in C and D, they're talking more about the mean, which would tell us who spent less or more time on average washing dishes. So answer choice C says restaurant A spends less time on washing dishes than B and C because it has the lowest mean. So if we go up here and look, the mean of restaurant A is 46.7. The mean of B and C are larger than that. So that makes C a true statement. And then restaurant C spends more time than A and B because it has the highest mean. We know that's not true because B has the highest mean. So our answer to question 6 is C. All right, y'all. So now I would encourage you guys to go directly to the Google form and practice this on your own. In that Google form, remember, there are places for you to ask questions in your collaboration document so that you can get some help. And as soon as you submit that, feedback will be sent to you on any of the questions that you missed. Hope you all are doing well, and we'll see you tomorrow.